So now that we've had a look at where binomial distribution comes in handy, i.e. when we have probability trees where the probability stays the same, but we have a lot of times that we're having to do it, we're going to have a look at how that can be simplified using the binomial distribution. So we use the binomial distribution. We have a situation in which a probability experiment is repeated a fixed number of times with an identical probability of success each time. So for example, if we roll the dice 7 times and we're looking for the probability that we get exactly 5 6s. Now the notation that we use is this here, which means that x follows the binomial distribution, and then we say n is the number of trials and p is the probability of success. So if we were trying to write the example that we have here in this notation, where we're looking at x follows the binomial distribution and we're rolling the dice 7 times, so our n number of trials is 7, and we're looking at the probability of getting exactly 5 6s, so the probability that we get 1 6, the probability of success each time, is 1 over 6. Now there is a formula for calculating the binomial probabilities for when we're looking for exact probabilities. However, in statistics we don't have to use this. If you are doing AS level maths, then yes, we have to understand this formula and use it, but we don't need to do it when we're doing this in the statistics A level. So instead, we're going to, in our calculator, be using the distribution function, which we can see here on F5, distribution. And we're looking at the binomial distribution, so we have to go into binomial. And for this first bit here, we're going to be going into BPD. And whenever we're looking at an exact probability, so equal to, we're looking in BPD. So in our calculator, in the statistics bit, we're going to dist, then binomial, and for this first part, we're going into BPD. So if we're looking at this question again here, we're wanting exactly 5 6s, so we're looking at the probability x. Remember, x is that we get a 6. We're wanting 5 6s. So in our calculator here, we're wanting x. How many successes are we wanting? Well, we're wanting 5 successes. We have 7 trials, and for the probability, if you just type in 1 divided by 6, it'll change that to a decimal for us, and that gives us this value here. So remember that this is written in standard form, and that means that we have 0.00188 to 3 significant figures. So for all of these following questions, we are going to be using BPD in our calculator. So for example, if we have a basketball player has a 60% chance of making a 3 throw, what is the probability that the player makes exactly 3 out of the next 6 free throws? So the distribution that we're using is x squiggle b. He's trying it 6 times and the probability is 0.6. Remember that this is that he makes a free throw. And we're looking for the probability that he makes exactly 3. So we're looking at the probability that he makes exactly 3 throws. So if we click exit in our calculator, we go back to this screen here. So this time we're wanting our number of successes to be 3 out of 6 that he's attempting, and the probability is 0.6, and that gives us 0.276. For question 2, we have a class has 7 students. What is the probability that exactly 4 of the students were born on a weekday, which is Monday through Friday? So this time we have X squiggle B. We have 7 students in the class. And the probability that they're born on Monday to Friday, well, that's 5 out of 7 days in a week. So this is looking at born on a weekday. And we're wanting to look at exactly 4. What's the probability that exactly 4 pupils were born on a weekday? So if we go back, there are 7 pupils in a class. The number of we're wanting 4 people to be born on a weekday. There are 7 people in the class, and the probability is 5 out of 7, which gives us 0.212. And then we have a class that has 5 students. So we've got X squiggle B, we've got 5 students this time. What is the probability that exactly 2 students were born on the weekend? So that's going to be 2 out of 7 this time. And this is born on a weekend. And we're wanting this to be exactly 2 students. So again back, we're wanting 2 successes, 2 people to be born on the weekend out of 5 people, and the probability is 2 out of 7, which gives us 0.297 to 3 significant figures. So carrying on with this, I'd like you to try the Now You Try questions. Remember to write down the distribution that you are using and the probability that you are finding in your calculator. Okay, so hopefully now you've paused the video and given the Now You Try questions a go. So for the first one, we have a hotel has 4 elevators and one of them is a freight elevator. And we're looking at when we push the button, one of the elevators randomly services your floor. If you use the elevator 7 times, so that's our N, what is the probability that the freight elevator comes exactly 4 times? So our number of trials is 7. Our probability, well, we're looking at the freight elevator, which is 1 out of the 4 elevators. So that gives us our probability. And we're looking for the probability that X equals 4, which ends up giving us 0.0577. For the second one, we've got an archer has a 25% chance of hitting the bullseye target. So that's our P. Find the probability that he hits exactly 3. So we're looking at probability of X equals 3 out of 5 times. So that's our N. And lastly, we've got the desks in a classroom are organised into 4 rows of 4. Each day the teacher randomly assigns you a desk. You can be assigned the same desk more than once over the course of 6 days. So that's our N. What is the probability that you are assigned a desk on the front row exactly 4 times? Well, if there's 4 rows and 4 columns, that means that there's 4 desks on the front row. So that gives our probability of 1 out of 4 because there's 16 in total. If we've got 4 desks going across and we've got 4 going back, then in total here we have 16 desks, 4 of which are on the front row, so that gives us a quarter. And we're looking exactly 4 times, so X equals 4, which gives us 0.0330. Now, sometimes questions aren't as simple as that. So here we have a school estimates the probability that a student passes an exam is 0.9. 5 students sit an exam. So that means our distribution is X squiggle B. 5 students are sitting it, and probability that we pass is 0.9. So this is looking at pass. Find the probability that fewer than 2 students pass. So this time the probability that we're actually looking at is X is less than 2, strictly less than 2, which means that we're looking at either nobody passes or, so plus, 1 person passes. So we need to find these 2 probabilities. So for the first one, nobody passes out of 5 and the probability of success is 0.9. So that gives us 0. Again, remember this is standard form, so 0.00001. Or one person passes, still out of 5 and a probability of 0.9 of success, which gives us 0.00045. And when we add those two together, we get 0.00046. I'd like you to pause the video quickly and try the Now You Try one. Okay, so hopefully you've given the Now You Try question a go. As you can see here, I've wrote down 2 different ways that you could have thought about it. If we're looking at the probability of x being less than or equal to 4, then you could have found the probability of it equaling 4 plus the probability of it equaling 3 plus 2 plus 1 plus 0. Or, after writing that down, we could have noticed that that meant that it would be 1 minus the probability of x equaling 5, because that's the only one that isn't there. And remember that all the probabilities are going to add up to give us 1. And if we have a look at that, dist, binomial, BPD. So equaling 5 out of 5, and the probability is 0.9. That gives us 0.59049. And then when we do 1 minus that, we get 0.40951, which to 3 significant figures gives us 0.410. So having a look at another example like this. According to recent data, the probability that a low-cost airline, Ryanair, loses a passenger's luggage is 0.05. I fly with Ryanair 6 times. So we're looking at X squiggle B. We fly with them 6 times and we have 0.05, and this is that they lose the luggage. Now we need to be careful because this is the information that we're given in the question. However, when we're asked to find a probability, it says the probability that I arrive with my luggage on more than 5 flights. Well, if this is looking at losing luggage, we can change this. Let's call this Y. And if they're still flying 6 times, if they lose it 0.05, then that means that they don't lose it 0.95 of the time. So that means that we arrive with luggage. So then if we're trying to find the probability that we arrive with the luggage on more than 5 flights, well, if we're looking at more than 5, so the probability that x is more than 5, the only number that satisfies is 6. And we're using the y, sorry, that should say y instead of x there because I'm looking at the changed distribution. And then if I come back out of this, sorry, dist, binomial, BPD, we're looking at 6 when we're doing it 6 times, and the probability is 0.95, which gives us 0.735 to 3 significant figures. If you didn't want to do that and you wanted to stick with the original loses luggage, well, if we arrive with the luggage on more than 5 flights, so that means that we want to lose the luggage on less than 1 flight, which means that we only want to lose, sorry, I've wrote the wrong letter again, talking about losing the luggage. So that means that we only want to lose the luggage 0 times. So this means this time we're looking at 0 out of the 6 flights with a probability of 0.05. And that gives us the exact same probability, 0.735 to 3 significant figures. So it's whether you want to think about it as arriving with the luggage or losing the luggage, just remembering that the probability is the opposite, it changes. So it's 1 minus 0.05, which gives us 0.95. Please pause the video now for a second and give the Now You Try go. Okay, so hopefully you've given the now you try a go. As you can see again, I've done this twice. Once thinking about the luggage arriving, once thinking about losing the luggage. And if we're talking about the luggage arriving, then we're looking at more than 4 flights, which means that we're looking at 5 or 6. And when we add those probabilities together, using the normal calculator bit of our graphical calculator, we get 0.967. If we're talking about losing the luggage, well, if it arrives on more than 4 flights, then we either lose it once or not at all. And then when we add those probabilities together, we end up with 0.967 again. Now notice when I was doing my working out in this part, I've kept my numbers to more than 3 significant figures when I was doing my adding, and then I've only rounded at the end, which is really important so that we don't end up with rounding errors. Now unfortunately, if we were looking at lots of these, so if we're looking at a large number of these, again, let's say that we're rolling a dice and we're wanting to know the probability of getting more than 20 sixes out of 30 rolls, then that means that we're going to have to be adding up a lot of numbers. So instead, we use a different function in our calculator, which is BCD, which we're going to go over next time. Thank you very much for listening.